Hello. So I recently bought a DXCommander antenna. It is set up in the end of the garden. You can see it here. The wire on the side is not part of the DXCommander. That is my G5RV antenna, which I used before. It's set up. The DXCommander is set up at the end of the garden, and I did some. The coax cable is running from the beginning of the picture to the DXCommander through the side of the garden. It's about 25 meters. I had some issues with the cables. First time I used the wrong cable, it was 75 ohm, and then you get really strange results. Then I replaced it by a better one, but also that one was not okay. It was too old. But I can show it in the measurement. So the next step is to measure the standing wave ratio for all the bands, and that I want to demonstrate here. Okay, so let's first measure the standing wave ratio of the coax cable with the dummy load. So I will go to the garden and connect the dummy load. So I want to show you the DXCommander, how I set it up. It's in the back of the garden. There is a ditch at the end. Yeah, the sunlight is not very strong, so let's go from a different direction. You can see it better. There's a freestanding, it's the base, but yeah, the back end is small, but the front end, the radials are in the front end on the ground. We can have a look at the base. So here it is connected.
So we are at the base of the antenna, and I disconnected the antenna and added connected to the dummy load here at the end of the cable. It's about 25 meters. So let's see what it does.
So I have the dummy load connected. First connect to the device. Okay. Set up my calibration. I calibrated before, so I can use the previous calibration. It's fine. Here it is. And do a sweep from 1 to 50 megahertz for the coax cable. And we can do 10 segments. So as you can see, the coax cable has some ripple. I think it's fine. The cable is not very new. It's an old one from my father's DX contest station. My father does not live anymore. He was 90 almost. But he was also a radio amateur, so I have a lot of stuff from him. The whole family was a radio amateur, or is a radio amateur. So you have a lot of gear left over. So maybe I later on replace this coax cable, but at least I had another coax cable also from the DX station, and that one was really bad. So you have to measure your cable if you use used cable. Check if it is correct, otherwise you're cutting cable, you're cutting the radius of the DXCommander, and it's going nowhere. So that's not what we want. So I'm at the base again, and as you can see, I connected the cable again. You can see all the elements of the antenna. I labeled them, but I ordered those cubes, but they were later delivered. So later on, I will put some markers on the radials. So you can see it is connected, and you can see the radials in the garden. So let's measure the antenna. Okay, I calibrated the NanoVNA, and let's try to do a sweep for 40 meters. And for some segments, so let's do 50 segments, 200 hertz per step. do a sweep. Put in some markers. There we are. So on the low end we have a standing wave ratio of 1.3 with 7.40 MHz, 1.0, and on the end of the band 1.1, so I think that's fine. I want to check the FT8. Let's see, FT8 is here somewhere, 1.1. So that's okay. So the next band is 30 meters, so that's somewhere at 10 megahertz. It's 10 to 11. Put in some markers. So at the low end is 1.1 and at the end of the band is 1.0. Yeah, ideally you could move it a little bit. And I think I need to add maybe a few centimeters to the wire. This is okay. Okay, so there's 30 meters. Let's check 20 meters. So let's do from 13.5 and 14.8. I had some problems with coax cables before. It really gave strange situations, so it's very wise to measure first with a dummy load. Let's put some markers also here. So on the low side 1.8, on 14.15 it is 1.2, and on the end it is 1.7. I don't know why it is not reaching, let's say, the 1.0 area. Something I have to research. Probably due to the radials. Because the DXCommander is now at the end of the garden, so my radials are more or less 180 degrees spread. I could, for an experiment, put it in the middle of the garden and make really a 360 degrees radial setup and see what is the difference. But for now it's too hot in the garden. Let's go to the next one. It's 70 meters. So let's go from 17.5 until 18.8. That's okay. Oh, I made a mistake, I think. 17.5 should be 17.5, yeah. Also put some markers. So at the beginning, so the dip is exactly at the beginning, and SWR of 1.3, and then it increases, and at the end of the band it's 1.5, 1.6. So I could shorten this one a little bit. Maybe I do. Okay, the next band is 15 meters. So 20.5 till 22. So 50 meters and 40 meters, they use the same radial. So I'm a little bit on the high side on 15 meters, but again, if I increase this one, then also 40 meters will change. And there is a document from DXCommander to how to optimize the 50 meters in together with 40 meters, so I have to check that. But yeah, between 1.6 and 1.0 at the end of the band, it's okay. But what is interesting is, why is this one going to 1.0 and the 12 meters and all the other ones don't? So that's a nice observation. So 12 meters is 24 megahertz. So 23.5. 25, do like this. Oh, it's a bit. Let's do 24.5 and then 26. Okay. It's a bit, yeah, that's a bit better. So I did a lot of checking with 12 meters. I added, I removed some length, and then I did too much, so I had to add a little bit again. And you have to be really careful with when you erect the DXCommander that you don't stretch the wires. So you really have to check if the pole is set up correctly, and that the guides do not twist the radials. I had it a few times. I did not. I was too quickly. So if you bring the pole down because you have to cut the wires, and you erect it again, have a good look if your radials are straight, and that you don't twist the antenna. Let's see. So it's 1.3. Hello. And then 1.5. So yeah. So I don't think I can make it much better. It can be because of the radial setup, and also the ground is very dry at the moment because it's very hot. Normally in Holland we have a lot of water, so maybe it improves. Okay, so 10 meters. Let's do from 28 to 30. Let's do from 27. Let's put in some markers. So at the start of the band, the dip and the end. So at the start it is 3, at the dip it is 1.3, and at the end is 3 again. So the optimum area, let's measure the optimum area. So let's put it on this line, 1.7, and the blue also 1.7. So now the optimum area is somewhere between 28.2 and 28.45, and that it is 1.6. I think it's okay for me. I mostly use FT8, so that will work. So I think it will be difficult to have the whole region quite flat. You have to optimize it somewhere. So I have to check what other people, maybe people can put in the comments what is their experience. So, but in all, I'm quite happy with this aerial, with this antenna, because the reception is very good, and also transmitting works very fine. So let's check the antenna. So I use a Drake tuner. Currently it's switched off. So if I put it here in FT8, I can switch to the other antenna. So this is the horizontal antenna. Well, I put it like this. This is the horizontal antenna. And then switch to the DXCommander. So it's doing good. You can also check 40 meters that I use the most. So I reduce the thing a little bit. So it's now in the morning, so conditions are a little bit less good. But it works fine. I don't know if there's anything on the higher bands. Oh, it's a bit empty. I have a spur from the, I think from the switching power supply, but anyway. 10, can we see the 7.4, is it? Or some CW. So all in all, I think it's a very nice antenna, and operates really fine for me. 73s, and good luck if you also have a DXCommander. See you.